Hello viewers, welcome back to my channel. Today I will be talking on how to program the treatment emergent adverse event by system organ class and preferred term table in SAS. So let's first see the mock or the table which we want to create. So right now I'm showing you the output table which we will be creating along with the values which we have. But right now we have to focus only on the format which we want to program. So there are few points which we have to observe that we need to do while programming is that first is that in titles we have 3 lines of title. The first title is the title table number, and then the second is the description of the table, and third is the description of the population set for which this table has been created. The second point to note here is that we are displaying the big N count value within the header part under each treatment of the study. Third point is that we are introducing a blank line below the header part and before each SOC is being displayed. The fourth point which we have to observe here is that we have to indent the PT value, which is the preferred term value, to few places to the right to make it distinctive to know that which row is the SOC values and which rows are the PT values. So in this way, we have to create the RTF file here. So let's see and proceed what code we will be writing. Okay, so starting, the first step is to read the library and read the ADSL dataset from that library. So right now I will be reading the ADSL dataset from my library, which I have given the name of Adam. So let's read this. So right now I'm showing you the ADSL dataset, which I have just read. Please note that I have kept only the uSubject ID and the safety flag because we need to create the table which is for the safety analysis set. And another thing we to observe is that I have kept the actual treatment variables because for safety flag, when we for any table for which we have to use the safety analysis set or the population set is safety analysis, then for that table, we will be using the actual treatment variable instead of the planned treatment variable. So since I will be needing only these four columns from ADSL, I have kept only these 4 columns in the ADSL dataset. The next step which I have done is I want to know the big N value. So there are many methods to get the big N value, but for me, for this program, what I have done is I have used the proc-SQL method to create the big N value as a macro variable, and I have used the percentage put statement to display the big N values for each treatment here. Let's observe one more thing, that in the ADSL dataset, we do have the total treatment as well. And the number for the treatment numeric variable is given as 99 for that. So because of that, along with the 3 treatment arms, we have a total treatment also in our ADSL. So because of that, when I'm creating the macro variables, I am creating the T1, T2, T3, and T4 as the big N values for each treatment from ADSL, where the safety flag is Y. So let's run this program and see what is the value. Please note that the percentage put statement will display the values in the log window. When I run this, I will have in the log window the values of each capital N, the big N values for each treatment. The treatment 1, which is placebo, is having 86 as the big N. The treatment 2 and treatment 3 is having 84 and 84, and the total, which is T4, will be having the value of 254, which you will see is the total of the 3 treatment count. So now we have achieved the big N value. So the next step is that we have to read the ADA dataset and we have to filter out the records where the treatment emergent flag is Y, because this table is for the treatment emergent SOC and PT records only. So another thing which we have to do while reading the ADAE dataset is, right now in ADAE dataset, we do not have the records where the treatment is having the value of total. So since we have to display the total treatment as well, so we have to create the total treatment records in ADAE. So how we can achieve is, when we are reading the ADAE dataset, after we have applied the required filter condition which we want to do, in this scenario, it is only the treatment emergent flag equals to Y condition. We have to use this statement, which is the output statement, because what it will do is it will read all the records which satisfy the given condition from ADAE, and it will create all those records in the resultant data set. The next step is that we are assigning the treatment TRT-AN and TRT-A. We are creating a new two variables with the value of 99 and total, and again creating using the output statement here. What it will do is it will replace it will create a new records for each records in your ADA with the TRT AE value as 99 here. So here by using these statements, we will achieve in that treatment emergent AE dataset which we are creating, that we will have all the records which were initially present in ADA satisfying the condition of treatment emergent flag as Y. Along with that, we will have the same records with the treatment value as 99, the numeric value as 99, but the character value as total. Please note that another thing which I am doing here is that in ADA, the TRT-AN and TRT-A variables are being used. So I'm renaming it to TRT-01A and TRT-01A, because in the next step, we will be merging these treatment emergent adverse event dataset with the ADSL dataset. And in ADSL dataset, we are only having the treatment TRT-01A or AN variables. We do not have the TRT-AN or A variables there. So, and again, another thing which I have done is I am again in the resultant treatment emergent adverse event dataset which I am creating, I am keeping only the required variables from the ADAE dataset. So right now from ADAE, I will only need the variables which are having the information of subject, the treatment information, the treatment emergent flag, and the SOC and PT values. The SOC comes from the AE boxes. So this is the variable I have kept. And since PT comes from the variable AED code, so I have kept the AED code as well. So let's run this and see what's the resultant of this data step. Here you can see that I have created the dataset, and we do have the variable TRT01A and TRT01AN created with, for each record, we have a record created for the total also. If you see if you compare the first two records, you will see that the only difference between the first two records is that for the second record, the TRT01A and the TRT01AN value has been changed to total and 99. Same is the case for the rest of the observations. So now the next step is that we have to merge these two datasets with the ADSL dataset to ensure that only the subjects which are present in ADSL and in our treatment emergent adverse event dataset which we just created are the ones which we are going to use later on to read the numbers of the subjects. So using the merge statement, I'm merging these two datasets, ADSL and treatment emergent adverse event dataset by use subject ID, and I'm applying the if condition that if A and B, which means that if a record is present in both ADSL as well as treatment emergent adverse event dataset, then only it should be created in the resultant ADAE dataset. And since we have to make sure that before merging, both the datasets are being sorted by the variables which we are using in the by statement. So I have pre-sorted the ADSL and treatment emergent adverse event dataset by use subject ID as well. So let's run and see. So the resultant ADAE dataset is created, and if you will notice here that we have all the variables which were coming from the ADA as well as the ADSL dataset. So we have the SAFFL flag also, which was coming from the ADSL dataset. And these were the last three columns are the columns which are coming from ADA dataset. So now we have created the dataset which we will be using to get the number of subjects for the different categories. Now let's go back to the RTF file, and we will see that which is the first record which we want to create here. So here you will see that apart from the SOC and PT values, we are also creating one record, which is the first record, which will give the number of subjects with at least one treatment emergent adverse event. So to get this, what we have to do is we will be reading the resultant ADAE dataset and we will see how many subjects are there. The distinct subjects are there in each treatment in this dataset to get the number of subjects in which are having at least one treatment emergent adverse event. Since we are, again, as I mentioned, that we have to count the distinct subjects, so we will make sure that we are not counting the same subject who is having two different adverse events from this dataset. We will be applying the no dup keep. So after applying the no dup keep to remove any duplicate records, here you might see that I have applied the no dup key twice. So let's go why it is being applied twice. The first no dup key is being applied by using the key variables as underscore or underscore. What does that mean is that when the ADA dataset will be sorted to remove the records which are duplicated, it will read based on the based on all the variables information. So what does that mean is that to identify which record is a duplicate record, it will read that it will make sure that both the observation which are coming in the first and the next consecutive record are having distinct values for all the columns here. In case if there is a scenario where the first thread record and the next consecutive record is having same values for both the records, then the first record will be kept and the second record will be deleted. So right now, why I am doing for all the observation for from ADA is because there can be a scenario where a subject who has experienced a particular adverse event. It might be repeated again with a different start date, with a different severity, and so on. So because of that, since we are keeping only the required variables in our ADA dataset, it will have both the records in the ADA dataset, and we want to read only the distinct subjects with the distinct AED code values or the AE bots values. So to achieve that, we have applied the no dup key to all the variables in ADA. So the next no dup key which I have applied is to, and I'm creating another data set, which is the ADA underscore, but here you see that I have applied the no dup key only to the variables, which is the treatment variable and the use subject ID. Why I am doing this is because now I want to count the number of subjects with at least one treatment and emergent adverse event. So what does that mean is that, for example, if a subject is having multiple adverse events and all those adverse events are categorized under the treatment and emergent adverse events, then I want to read that subject only once. let's see if we have any such scenario. Okay, so we have this subject. So let's see this, let's filter out this subject and understand in more clarity what does that mean. So here you can see for this subject, I have 3 records with the A boxes and the A decode values being different for all these 3 records. So if I want to read this subject in the first row, that is the number of subjects with having at least one treatment emergent adverse event, I have to read this as one record, yeah, or one subject ID. I do not want to read it as 3 different subject IDs. So to achieve this, what I have done, I have to do is that I have to remove the records where this subject is getting repeated again. So to achieve that, I have applied the no dupe key here by the treatment and the subject ID. So why I have applied the treatment also? Because we have to display the total treatment also. So to make sure that this subject is being counted in the total as well, I have to see that both the variables, that U subject ID and the treatment variable, is being used to in the by statement while removing the duplicate records. But for the same subject, when I want to see, when I want to read the number of subjects for each SOC and PT, in that scenario, you will see that this is the SOC value. So here we have 2 distinct SOCs being present. So I want to make sure that this subject should have a distinct, like this subject should be counted in the general disorder and administrative side condition SOC as well, and it should be read in the gastrointestinal disorders SOC as well. So to achieve that, I have initially applied the no dupe key to the all variables. So another point here is, if you notice the PT values for the general disorder and administrative side conditions SOC, we do have different PT values as well. So if I would have applied only the no dupe keep only for U subject ID treatment and A boxes, we will have wrongly deleted one of the PT values for this SOC. So that is something which would have not been correct. So I want to make sure that we have the distinct records for all the combination of all these variables. So to achieve that, I have to apply the no dupe key for on the treatment and U subject ID variable. So having understood on the reason why we have applied the no dupe key, now let's run the proc frequency procedure on the ADA underscore dataset which I have created to know the number of subjects with at least one treatment emergent adverse event in each treatment. So right now I am using the treatment variable, which is the numeric treatment variable TRT01AN in my table statement to get the number of subjects. So let's run this and see the output. You can see that after running the proc frequency procedure, using the table in the table statement using the treatment 01AN variable, I'm getting the count for each treatment. What is the count of number of subjects in that category? So here you can see that for the first treatment, which is placebo, I have 65 subjects in which are having at least one treatment and emergent adverse event. So similarly, for the remaining treatment also, we are getting the count. Now, this is the value of n, the small n. But if you see, we have to display the percentage value as well, the n percentage. So what is n percentage? N percentage is the small n, which is the sample size here, and divided by the capital N, which is the big N, into 100. So to achieve this, what I have done is, the next step, I have use the resultant AE dataset, which is the dataset I have created from the proc frequency. And in that dataset, I have created a new variable, which is the variable var. And based on whether the treatment is placebo, high dose, low dose, or total, I'm using the macro variables which I have created earlier, the big and macro variables for each treatment, and I'm counting the n percentage value here. So if you see here that in this record, what I am doing is that when the treatment 01 an variable is 0, then the var will be calculated as first is that we have to display the n, which is this part. So this part, how we are doing is that we are converting the count variable which is in this A data set. It is in the numeric format. So we have to convert it into the character format. And for that, we have used the put function using the best dot format, and using this put function, it will be converted to character. To ensure that we are not having any leading or trailing spaces from the resultant conversion, we are applying a strip function. So using this this part of the code, the value of count is getting converted to character with no leading or trailing spaces. The next step is to get the n percentage values in brackets. So we have concatenated the opening bracket first using the pipe delimiter, and inside the closing bracket also we are again doing some evaluation. So again, what we are doing is we are here, if you see, we are counting the n percentage, which is n, which count is the small n, the ampersand t1 dot, which is the macro variable for the big N value for treatment 0 is here. So I'm dividing that by capital N value multiplied by 100. This part of the code will give me the n percentage value. But since the n percentage value can have many decimal value places, I do not want to display the whole decimal values in my table, but I want to display only till the first decimal value. So to achieve that, what I have done is I have applied the round function and have limited it using the modifier as 0.1. I have told the SAS that change the decimal values to the one decimal value count. So what it will do is, sorry about that. So what it will do is that it will round off the resultant n percentage value to one decimal value. So now again, this value is a numeric value. So I want to convert it into the character format. I'm again using the put function with the best dot format, and again applying the strip to ensure there is no leading trailing spaces, and then closing the parentheses here. So in this way, what I have done is I have created the n and in bracket n percentage value. So the same code I have used for the other treatments also, but the only difference is that while counting the n percentage, I have made sure that I am passing the big N values of that respective treatment here. So for treatment, the second treatment, which is the numeric value of 54, I have given T2 macro variable. For third one, we have T3, and for total, we have the T4. Another thing which I have done is that I have created a column by the name of label, and I have given the text value which I have to display in my RTF file also. So you can see that here the text value which I want to display is the number of subject with at least one treatment emergent adverse event. So I have given the same value to my label column here. So let's run this and see what is the resultant data set. So here you can see we have all the 4 treatment values. We have the label for all the treatments, and we have created the var, which is the n, and in brackets the n percentage value. So, and now the next step is that we have, this is in the long view. So I have to, like, long view means that it is in the row. We, for each treatment we have a different row, but I want to display it, all the treatment information in one row. So I have to transpose this where column in for each treatment, creating a one record having different columns for each treatment. So to achieve this, what I have done is I have to use proc transpose. So here, what I have to keep, I want to keep a label columns where the record will have the label value, and I want to create 4 columns with the values of treatment 1, 2, and 3, 4 with their respective values of the where column here. So to achieve it, what we have to do is we use proc transpose. We are outputting a new data set, which means we are creating a new data set by the name of AE2, and we have given a prefix here, which is equals to TRT. So what it will do is prefix works with the ID statement here. So the variable which we mention in ID, that variable values will have the prefix as TRT. So now, as you can see that here that the TRT01A is a numeric value. So when I provide a prefix equals to TRT, what it will do is it will name the column as TRT0, TRT54, TRT81, and TRT99. And since I want a column which is the label column, so I am using that column in the by statement, and I want to transpose the count, the where column. So I have in the where statement, I have used the where column here. So applying this, we will run the proc transpose, and you will see that we have one column label, which is the number of subjects with at least one treatment emergent, and for each treatment we have the value of where being transposed. So this is the way which what we have achieved so far is we have created the first row which we want to display. So now next thing is that we want to create the similar format for these SOC and PT values. So what we can do on this part is we will repeat the steps which we have already done. The only difference is that what we want to do is that first is we want to have the number of subjects for each SOC. And similarly, we want to have the number of subjects for each PT by each treatment. So when we are we want to create the treatment emergent by SOC PT, which is like I want to have the number of by each SOC here, SOC and PT, I will create the proc frequency with the 3-way table statement. So here, since I want to have the count by each PT for each SOC, I am using the treatment variable, then the asterisk sign, then the A boxes, which is my SOC, and the asterisk sign, which is after which I have the PT variable, which is the AED code. So what it will do is it will give me the number of subjects having a particular PT for a particular SOC in a particular treatment. So let's run and see the output of it. So you can see here that for each, there will be another rows. For each treatment, for each SOCs, and for the respective AED code values, which is the PT values in that particular SOC, I will have the number of subjects in the count variable here. So if I remove this, you can see that we have the SOC by treatment, by SOC and PT, I have got the count. Similarly, what I have achieved so far is I have achieved this count, that is the by PT count for each subject in each SOC. I have got the N value I have got. So now similarly, I have to get the N values for each SOC as well. So for that, I will, since I want only by SOC, I do not want to the second layer of segregation. So I am only using the two-way table statement here, and I'm getting the number of subjects for each boxes, which is the SOC, and for each treatment. So when I run this, I will have the same format, but I will not have the PT column. So now for each treatment, I will have the each boxes which is there and the number of subjects in that category. Okay, so now you will see that let's see these two tables side by side first. Let's apply a filter to better understand the scenario. So you can see that in the SOC PT dataset which we have just created, I have applied a filter for the first treatment and the first SOC, and that is the cardiac disorders. And you can see that in this, we have multiple PT values and their respective count. Now in the second dataset which we have created, which is the SOC dataset, here also I will apply the same filter, which is the for first treatment and first boxes, which is the cardiac disorder. Here you can see that I am getting the values of number of subjects in that SOC. So here, if you observe that this record is my record, which is the record which I have to display for SOC. And the rest of the records here are the records which are having the information of the PT values in that particular boxes or the SOC. So right now, what I have achieved so far, which I'm showing you right now, is that I have got the number of count for the SOC level. I have got in one table, and I have got the number of subjects count in PT level for SOC and PT level in another data set. So to club these two to have in this particular order, that is, I have the SOC count as well as the PT count all together in one data. What I have to do is I have to set these two tables together, and what will be the result of it is when I'm setting these two data, all these 5 columns will be created in the resultant data, but the record coming from the SOC value will not have my A decode value for that scenario. Let's see first what does that mean. So let me run till this set statement here that I'm setting here. I'm not showing you what modification I have done so far. So here, if I filter on this same scenario, which we have just seen, so you can see we are now having one record where is the first record is the record where only the SOC is having and it's the count, and the second record onwards there are records which are having the PT level count set below that, right? So now let's do the modifications which we have to do. So as we have done in earlier data set to create the number of subjects in having at least one PT. So same way, we will be creating a where column for the each treatment here. The same, we are applying the same code here. So that will create the where column. But to create the label column, which is the first column which we have to display here you will see that we have to display the SOC and the PT, but the PT has to be intended some spaces to the right. So to achieve it, what we will have to see few things here. As I have shown you that for the records which is having the count of SOC level count, the A decode value was null. So using that information, what I have done is I have again creating the same label column here, but I have I am creating the label value in two scenarios, that when the A decode value is null, what will be the case here? This will be the case when the SOC record are being kept from my SOC dataset. So in that scenario, I want the label to have the A boxes value only. So here, I have removed that. So here it will keep the A boxes value, and I'm converting it to prop case, which is normally the case when we display the SOC or PT values in the table. And so that is the first condition. The second condition is that else, like apart from the case where the decode value is not equals to null, in that case I have to uh, populate the label as my decode value, but since I want to indent the decode values to few character length to the right, what I have done is I have concatenated by 3 spaces in front of a decode. So let's run this, and again I'm keeping the required variables from here, which is the treatment, label, var, boxes, and decode. So if I run the resultant SOC PT dataset, I'm also running the sort also, that this dataset should be sorted by boxes, decode, and treatment to have a better display of the data. So now you can see that here the label, the cardiac, now since we have sorted it based on the boxes, decode, and the TRT variable here, so the first records will have all the boxes which are coming for the cardiac disorder. Then the second level sorting was for AE decode. So since missing values are considered first in sorting, so all the records which are having the A decode as missing, that is the records which is having the SOC level count is being displayed first, and then the A decode values in the alphabetical order. So here you can see that when A decode was null, I have created the label with having the value of A boxes with the var value, which is the n, and in brackets the n percentage. And for this case where I have to display my PT values, the label is having the PT in my prop case, but there is a 3 character length indentation happened for my PT values. So this way my variables are being created. So now again, as you see that the first 4 rows are the rows which are having the information of my cardiac disorder. That is the first SOC to be displayed in the table here, but it has to be transposed to be in the longer view and not into the narrow view. So the next step will be the step to apply the proc transpose to this resultant data set. Here again, I'm using the same code that I'm using the prefix as TRT, and ID variable is my TRT01AD, var is the var variable which I want to transpose. But here, since I want to display my I want to keep my A boxes decode and label for each row, I have kept those variables in my by statement. So let's run the proc transpose. So yeah, so you can see it is in the same format which we want to display. You have the label, you have the PT with the indentation required, you have the n percentage values for each treatment coming as a column value here. So this is the data set which we have created. That is the second part of the output which we want to do. Now, the final step is to set both the dataset in which we have created the first record and the dataset which we have created the second section of the program. So I'm creating the dataset fin, and I'm setting the 2 dataset, which is AE2 and the SOCPT2 here. Another thing which I am doing here is that for the records where the values for the treatment values are missing. Missing means, let's see the scenario again. So here for this particular SOC PT, which is cardiac disorder SOC and atrial flutter as PT, we do not have any subject who have received who have encountered this particular adverse event in our treatment one, which is the placebo treatment. Because of that, it is coming as missing. But in the final output, we do not want to display it as missing, but instead we want to display it as 0. Same is the case for the other three treatments, that where the values are missing, we have to display as 0. So to achieve that, the last level of modification which we are doing is that in the resultant FIN dataset, for the records where the TRT0 is having a missing value, display 0. And same is the case for 54 and 81. Please note that the TRT99 is a total column. So there will never be a scenario where the TRT91 will have a missing value. So because of that, I have not used for the TRT99 filter condition here, that where the TRT99 is missing, converted to 0. So I'm keeping the required variables, which is label, treatment, decode, and boxes. So let's run this and see the output. So now we have got the 0 for the cases where it was missing. And we have the boxes and decode values also. And we have the first row, which is the number of subjects with at least one treatment emergent adverse event. Then we have the first SOC and their respective PT. We have the second SOC and their respective PT, which is only one in this scenario, third, and so on. So this is our final data set, which is looking good, which we can use now to display in the RTF. Just sorting the data set by the AE boxes decode and label value. So what we have achieved so far is that we have achieved the intended values for PT. We have achieved the first row. We have achieved the SOC PT values. As we discussed earlier, that we want to introduce a blank line before the first record is being displayed, or after the header, and for each records prior to any SOC being displayed. To achieve that, we have to do some further modification in our resultant data set, which is the FIN data set. Okay, so now here, let's consider from the label column here. In my resultant data set, I have the label column, and what I want to do is I want to introduce a blank line before the first value of my label and before the first value of each SOC, right? So that we have to introduce a blank line here. So how we can achieve is that when we will be creating another data set, let's say by the name of FIN2, and we will be sorting it. We will be setting the FIN data set, but we will be sorting this data set and using the by statement, that is by AE boxes, AE decode, and label. And using the retain function, I am creating another variable, which is my PG, which I will be using to introduce the blank line here. So what I'm doing here is that when this FIN dataset is being read in my FIN2 dataset, and the first record is being read, the underscore n underscore will have the information of the observation that is being read. So when the scenario that the first record is being read, that is underscore n underscore is equals to 1, then I'm assigning my PG value equals to 1. The next step which I have done is that when it will encounter the first occurrence of the any boxes value, the SOC values, and it is not the first record which is being read, then the PG value will get incremented to 1. What does that mean? That means then when the compiler will move to the first occurrence of my AE boxes. If you see the first occurrence here, This was also a first occurrence, but here I have already applied a condition that when the n and the underscore n underscore value is 1, for that I am giving the PG value as 1. So the second scenario is that when it is reading the first occurrence, but it is not the first record of the data set, in that scenario, the PG value should be incremented to 1. So here when I assigned it to PG equals to 1, when it will read the first occurrence of SOC, which is cardiac disorder, it will uh, increment the PG value by, and the PG value will be 2. And until the next occurrence of the SOC value, the PG value will remain as 1. So in this way, I have created a PG variable here, and let's see the values for that variable. So here you see that for first record, I have assigned the value 1, and for the first the occurrence of each SOC values, which was the first here is the cardiac disorder, it has incremented the value to 2. But for the next few records where we are displaying the PT values, which is not the first occurrence of SOC, the PG value is not being incremented and it is being retained as 2. And when the next first occurrence of my SOC has happened, then it is incremented to 2, incremented to 3, and so on, on the next first occurrence of any SOC values. So in this way, I have created a PG value variables having the numeric value. So now let's read my FIN2 data in proc report to generate the RTF. Again, now here, as I've mentioned in my earlier videos also, normally any organization have a macro being used to assign the ODS statements. So if in your organization also there is a macro used for the ODS statements, you use those macro and you only define your proc report accordingly. If you are not having any such macros in your organization, the base I'm right now what I'm using is the basic steps for ODS statements, which will result in the creation of my RTF file. So here, what we have to do is since I have to generate the RTF file, I am using the ODS RTF file statement, and I'm assigning the path and the file name. So the RTF file which will be generated, it will have the name as treatment emergent adverse event underscore SOC underscore PT, and I have given the extension of RTF, and it will be saved in my the path which I have given here. And right now I'm just giving the style as general, but again, depending on your study requirement, you can change the style here. And the next step which I have used is the ODS escape character, and I have given a blank space here in this case. So what does this will do is that when it will read the label column in my proc report and will generate the RTF, it will not trim the blank spaces which we have introduced in the PT value for indentation. To ensure that it is not being removed, the first thing we can do is we can tell this SAS that we are using the blank spaces as the escape vector. Another thing which we will have to do is that we have, while defining the defined statement for label column, we will have to use the ACES equals to on functionality for column style. So these two things we will have to ensure to while defining the label, that the values which are present in my label column will be displayed as it is in my RTF file without any further modification resultant from the ODS statements. So let's check the proc report, what we have done here. I'm reading the FIN2 dataset, and to ensure I'm using the full width of the page and I'm not creating any border lines. I have given the style report where I'm removing any border lines, and I am giving the width equals to 100% to ensure that the complete width of the page is being used. The next is we have to define the columns which we are going to display. So right now you can see that although we are displaying the label and all the 4 treatments, but I have also given the column which is PG. But in the output, we will not be displaying the PG, but why we have kept it in the columns? We have kept it because we will need this column PG to introduce the blank line, and we will, while defining the PG column, we will mention that we will mention the no print option because it will tell this as that we will be using PG later on in the proc report, and we do not want to display it in the RTF file. Another thing which we will have to do is we have to assign it as the group analysis. So for that we have mentioned it as grouping as group here. So for the next 4, the labels, as I've told you that for label we have used the define label in the display. We are giving the header, which is the SOC the system organ class, and by space as the preferred term. And then since we do not want any further modifications being done on this column, we are mentioning the style on column as s is equals to on, and we are left justifying the header and giving the width for this column as 40. For the treatment columns, again, you can see that we are giving the columns, each treatment description here. But along with that, in brackets, what we have done is we are giving n equals to a macro variable. So what we are doing here is this, as I told you earlier, that we have to display the big N value in the header here. So to achieve that, I am mentioning that in brackets n equals to and passing the macro variable for the big N macro variable which we have created at the start of the program for each treatment here. The T1 was for placebo, T2 was for high dose, T3 for low dose, and T4 for total. So accordingly, we have mentioned that macro variable in n equals to in brackets n equals to and then the macro variables. Another point to note observe here is that since we are mentioning a macro variable, make sure that when you assign the title or the header here, you are using a double quotes for that. If you will use single quotes to define the title description or the header description here, the macro variable will not get resolved and it might throw a warning or an error message in the log later on. So when you are using a macro variable, make sure it is enclosed within a double quotes here. So we have defined use the define statement for each column. So now the only step left is that we have to introduce a blank line here. So that can be achieved using the compute block. So now how to achieve it? Since as we have observed that we have to introduce prior, like before the occurrence of each SOC or before the first line of the record being read, here we have used the before option here. So PG will have the value of 1, 2, 3, 4 for each records, and for each new occurrence, each new values of PG, before that we are introducing a line here, and here you can see that we have used the statement line and in brackets the blank line to tell us that for each occurrence of my PG value, I have to introduce a blank line before. So I will use the compute block in this way. I will end the compute block. The next here is, again, this is something which I am using because I'm mentioning the title and footnote inside my proc report because I am not using any macros to create the titles and footnotes. Normally, each and every organization have their own macros to display the titles and footnotes. So in that scenario, you will not need to write any title footnote statements in your proc report procedure. So in my title, I want to display three titles. The first title is my title table number. The second is my title table description. The third is my population set, which is being used. So what I have done is for the first title, I have used the title keyword and given in brackets the title which I want to display, which is the title table number. The second title will have the title as title 2, title 3 for third, and so on. If we have any further title 4 and more than that. So here I have given the title description of the table, the population set as my third title. And similarly, in the footnotes, right now I am just giving the today's date that it was generated by SAS and the date this program was run, this RTF file was created. If you have multiple footnotes, you can again use the same functionality as we have done for title, that for second footnote, you can use footnote 2 and in brackets that footnote and footnote 3 and so on. So at the last, I'm closing the RTF, the ODS RTF statements by ODS RTF close. So let's run this. It will generate the RTF and it will save the RTF here in this particular location, and it will also display the proc report result in my result window. So let's see the result first in my result window. So you can see that I have got all the three titles. I have got the header as system organ class preferred term, and for each treatment I have the treatment description along with the n value, the big N value, and then we have introduced a blank line before the start of the first observation or before the start of any SOC. We have got the indentation for PT values as well, and we at the last we have the footnote as well. So now let's see the RTF file also, whether the same thing is in the RTF file as well or not. Let me close the RTF file which I have already was showing you, and says this is the RTF file name, which is the treatment emergent adverse event SOC PT. So I will be opening this. First, it will get downloaded, and I'm opening it. So you can see that this was the one which we want to create. So it has been created correctly. We have the three titles. We have the header part, the N values, the blank lines, the indentation in my PT values, and the NN percentage values. So it seems to be fine. We have the footnotes for each page also. So in this way, you can create the treatment emergent adverse event by system organ class and preferred term. This is right now the program which I have shown you was for the safety analysis set, but if you want to create this particular table for any population set other than safety analysis set, then the only difference is that you have to filter out the, you have to apply the filter on that particular population set in the ADSL while reading the data. So hope you like this video. Let me know if you need any further information on this particular topic, or you want me to cover any specific topic in my next videos. Do let me know in the comments. Till then, thanks for watching. Have a nice day.